Assalamu alaikum. This is a question on kinematics using a polar coordinate system. We have the slotted arm AB drives pin C through the spiral groove described by the equation given by R equal 1.5 theta feet. So now what we have? We have this pin C is being driven by this arm going through this groove, right? And theta here is in radians. If the arm starts from rest when theta equals 60 degrees and is driven at an angular velocity 4 times t radian per second, and t here is the time. Now this is the theta dot, right? So we can remind ourselves here that this is here simply is theta dot, and t here is in seconds. The question says determine the radial and transverse components of velocity and acceleration of the pin when time equal 1 second. Okay, so we need to determine these quantities: Vr, radial velocity, V theta, transverse velocity, Ar, radial acceleration, and A theta, the transverse acceleration. Okay. Okay, now to start with, Vr is simply R dot, right? And V theta is R theta dot, and AR is R double dot minus R theta dot square, and A theta, the transverse acceleration, is R theta double dot plus 2 R dot theta dot. Now to make things easier, let us evaluate R dot and theta dot, and also R double dot and theta double dot. Then we can plug in these equations. Okay, R is given to be 1.5 theta. Okay, so this is R. So R dot, remember we are taking the derivative with respect to time. So R dot is 1.5 theta dot. And R double dot would be simply 1.5 theta double dot. And theta dot here, theta dot is given to be 4t. Remember, theta dot is the angular velocity, so it's already given. Theta dot is 4t, and hence theta double dot. Now we need to take the time derivative, and theta dot is already a function of time, so theta double dot simply is 4. Okay, now let us plug this into the equation, and see what we can find. Now from here, Vr simply is 1.5 theta dot, right? And equals 1.5. Now we can replace theta dot by by this parametric equation 40. So I'm going to replace this one by 40. So 1.5 times 40. Okay, and this is simply 60. Now the question wants us to find this at time equal 1. So now Vr looks ready. We can just replace the time by whatever we have here. So now if we do that, Vr at 1 second, just fix that, at 1 simply is going to be 6 feet per second. Okay, now for V theta, the transverse velocity, we have V theta simply is R theta dot equals R is 1.5 theta, and theta dot is 4t, right? So we will have 6 times theta times t. Now we need to find, we want to find this, the transverse velocity at time equal 1. But now here in this case here, we have a problem, which is what is theta. So now we need to find theta at time equals 1, right? So try to think, how can we do that? Now, since we have theta dot here given 40, I can write, so now let me do it here. Since I know that theta dot is given to be 40, okay, which means now d theta over dt, which is theta dot, is also equal 40, right? So now we can separate the variables and integrate both sides. So I have now d theta equals 40 dt. Now integrating both sides. Right, now about the integration limits here. When we start from this, the question says theta is 60. Now remember, 60 is in degrees, right? And we need to convert it to radians, because this equation is given in radians, right? So now 60 degrees in radian is simply pi over 3, right? So 180 over 3 is 60. So here from pi over 3 for theta until just any theta. Okay, and now here for the time, from rest means we have just started now, so from 0. Now I want to find this theta at 1. So we can do this, from the 0 to t, then replace t by 1, or simply you can directly put here 1, right? And now just finding this, doing this integral, we'll find the relation between theta and t. So now if we do that, let me evaluate this integral. I'll have the d theta from pi over 3 to theta. I'll have theta minus pi over 3 equals, now doing this integral for t, this will be 40 square over 2, which is 2t square, right? This is from 0 to 1. So now if we replace t by 1, I will have this is equal to so just 2 times 1 square minus 2 times 0, so equals to 2, right? So now I have found this relation. Theta is simply at time equal 1 is 2 plus pi over 3. Now we did this just to find this theta here. So now I can replace this theta by this quantity here. So I have this now equals, let me do it here. So equals to 6 times 2 plus pi over 3, and we are finding this at 1, so times 1. Then we can just plug this into the calculator and find our answer. Okay, so let me do this. So here I got 18.3 feet per second. Okay, now let us look at the acceleration now, AR and A theta. You open a new page. Now AR is simply R double dot minus R theta dot square equals, now we have found R double dot to be 1.5 theta double dot minus R, which is just 1.5 theta, and theta dot square. Now theta dot is given, the angular velocity is given to be just 40, right? So times but here we have square, so 4t square, 4t square, okay, equals. Now if we replace these quantities, 1.5, now theta double dot, we have found that to be just 4, so times 4 minus 1.5 times, now again this theta here is the theta, is the angle at times 1, right? So we have found that to be just a number, which is 2 plus pi over 3, right, times 4 square, 16, times t square, which is, now we need to find it at 1, so times 1 square, okay. And, you know, put here everything into the calculator. Let me do this. Okay, so now here I have found this to be negative 67.1 to 3 significant figures feet per second square. Okay, so that's the this is the radial acceleration. Finally, now we have the transverse acceleration a theta. This is r theta double dot plus 2 r dot theta dot, and again we're just replacing these quantities. R is 1.5 theta, right? Theta double dot, the angle, by the way, theta double dot here is the angular acceleration, right? So just remember that. Okay, so r 1.5 theta, theta double dot is, so times 4 plus 2 times r dot, which is 1.5 theta dot, and theta dot here is 4t, okay, equals, now we're replacing this 1.5 times theta at times 1, so now I want to find here t equal 1, right, and here also t equal 1, so 1.5 times 2 plus pi over 3 times 4 plus 2 times 1.5, and theta dot is simply 40. This one here is 40, so 4 times 1, and again we have another 4 times t here, okay, which is again 4 times 1, 4 times 1, okay. Okay, now we have putting this into the calculator. Okay, so now we get a positive number here. Okay, I got 66.3 feet per second square. Okay, and that's it. This answers the question. I hope you find that useful. Please support the channel by liking and sharing the video, and also let us know in the comment if you have questions, or if you want me to explain certain concept or solve certain problem. Please let us know. Wishing you all a good luck.